Okay, I'm going to switch over to Unity. And the next thing to do would be to add collectibles, namely over here in the sprites, these pickups right here. I'm gonna add a bunch of them around the screen or around my game area, so that when the UFO makes a collision with any of these pickups, that they automatically will disappear. So let me go ahead and take the pickup and I'll drag and drop it into the hierarchy. And let's see what's going on. So first of all, in terms of the player, let me just disable that temporarily so that we don't see that. So I'll just click this checkbox. And then over here, I'm going to select pickup and then select the sorting layer default. Oh, we don't have anything that's called pickup. Well, in this case, I want to do the plural pickups. So I'll go ahead and click on add sorting layer. And I'm going to click the plus symbol and we'll say pickups. Okay, and the way that we'll make it is so that the background is at the bottom, then pickups will be in between, and then player will be at the very top. All right, so now I'm going to go back over here to pickup and go to the sorting layer, and I'll specifically say pickups. All right, so now we can see the pickups, or this particular individual pickups. My intention is to create a bunch of these and copy and paste them and place them around kind of like in a circle. So before I do that, I'd better go ahead and place a circle collider or collider around this. So let me just zoom in really closely here. With the pickup selected, I'm going to go ahead and click on Add Component. And then we'll go to Physics 2D. And let's see how good we can do in terms of encapsulating this with the Circle Collider 2D. Now, it may be very difficult for you to see the green circle that is around this pickup. On your monitor, I'm sure it'll appear a little bit better, but let me go ahead and tighten up that radius, and let's say something like that looks pretty good. I know that there's a little bit sticking out over here, and there's a little bit that's not being covered here and here, but I think that's good enough, especially when we zoom out. So once we have this, let's go ahead and save our work by clicking File and Save Project so that we can continue from here. Well, the next thing to consider is how this is going to appear on the screen. I've already described how I'm going to be placing several of these around the game board area, but what I would really also like to do is to have this thing have some sort of an animation. Maybe what we'll do is we'll have it spin around. And so what I'll do is I'll generate the code to make this thing spin around while we're playing the game. So with pickup selected, I'll need to add a new component, and we'll scroll all the way down to the bottom and click on New Script. So for the new script, let me click on that. Let's just type in rotator. Okay, so this is the rotator script, and so I'll press enter, and now you'll see that with the pickup selected in a second, you'll see that the script, there it is, there's the rotator script, is now available. By the way, I know that that's not going to be inserted into the scripts folder, so I'll have to click on assets, and sure enough, there's the rotator script. Let me take this, drag and drop it into the scripts folder. That way our scripts folder has a nice collection, right? A neat collection of all the various scripts. All right, so if I go back over here and making sure that pickup is selected, and so there it is, the rotator script, I can go ahead and click on the drop down for the gear, and then we can just say edit script, and that's going to take me automatically into Visual Studio where I can go ahead and type in the code. So let's go ahead and place your cursor inside of the update function, and you recall that update is used, or it's called rather, once per frame. That's different from late update, which means perform the calculation then update. That's different from fixed update that we used for physics applications. And so this really isn't a physics application. This is simply a transform rotation application. So update is fine for that. What we're going to do is we're going to say transform dot rotate, which is this guy right here. What does it say? For rotate, applies a rotation of Euler angles degrees around the z-axis, Euler angles x around the x-axis, Euler angles y around the y-axis, in that order. Okay, so what we're going to do is, let's see here, it says z, right? Z degrees and the z-axis, x and y, in that order. Okay, so I'm going to click on rotate. I'm going to put parens, And then inside the parens, what we need to do is we need to have a vector 3 item. All right, well, in order to get a vector 3 item, we're going to have to type in new. We're going to instantiate a new vector 3. Let me go ahead and put open close parens. What do you need? Well, the vector 3 needs 3 different items, namely the x, y, and z axis. In fact, if I click on this triangle, it will give me an option to see the different items that it needs, or these are the different flavors. It looks like the x-axis angle, the y-axis angle, the z-axis angle. Okay, so what I'm going to do here is I'm going to type in 0, 0, 45. Close the parentheses. There's the outside parentheses. I'm going to put my semicolon right over there. So what that is going to do is it's going to say rotate about the z-axis 45 degrees. So let me go back over here to Unity. So we would call this left and right the x-axis. We would go to the top and the bottom. We would call that the y-axis. And then I want you to imagine from this point a line that's going straight to your eye. We call that the z-axis. So the z-axis is literally an arrow coming out of the screen. And from the z-axis, that's how I want this thing to spin. And that's what we're basically saying that this thing needs to do. All right, so what's going to happen is we want this thing to be smooth. So I'm going to type in this additional code in between these two parentheses. And what I'm going to say is, in terms of time, dot, notice that there is an option over here that says delta time. And what does that say? The completion time in seconds since the last frame. Okay, so I'm going to select this guy right here, and then we can just simply move our cursor to the outside. The reason why we need this is because we want there to be smooth delivery independent of how many times that this is being called. The update function is being called once per frame, but if this runs on a slower computer or a faster computer, that rotation could look different. So we're saying independent of time. We want this thing to have a smooth transition, and that's what this code is really necessary for. Well, before we run the program, let's go ahead and click File and save our work. Then we can switch back over here to Unity, and let's go ahead and run the game and see the effect that it has on the pickup. And as you can see here, it's rotating. I like how smooth it's rotating, pretty nice. By the way, there's something else that we can do. See over here where it says maximize on play. So I can click that guy. Let me stop the game. Let me start it again. And basically you're entering into like full screen mode. And so you can see the effect that it has. Our gameplay is taking the entire screen. That looks pretty nice. I like how smooth that's running. So I'm going to click on maximize on play. I'm going to take that off, stop the game. So if I did start the game again, it would only take this area right here in terms of playing the game. Okay, another thing that I want to take a look at is a deeper look at what's happening to the code. Let's do this. Let's change this to -45 and see what happens. So I'm going to save, and I'm going to switch back over here to Unity, and let's run this and see what happens. Okay, here we go. All right, so it looks like with a -45, this thing is rotating counter, or clockwise rather. And by the way, let me go ahead and click on this guy, stats. So it looks like in terms of frames per second with my computer, and I got a 4-year-old, I don't know, maybe even a 5-year-old laptop. It looks like this is rotating at about 90 frames per second, or it's operating, I should say, not rotating, it's operating at 90 frames per second, looks on average. Okay, let's stop the program. So remember, clockwise. Stop the program, let's go back over here, let's take away that negative, save my work, switch back over here to Unity, and let's run the program again. Now before it was rotating clockwise, but now you can see it's counterclockwise. Okay, so in terms of direction, that's just simply going to be the value that you apply to, in this case, the z-axis rotation. If it's going to be negative, it's clockwise. If it's positive, it's going to be counterclockwise. All right, let's dive in a little bit more into, why is this necessary? All right, so what I'm going to do is I'm just going to put a close parentheses and a semicolon, and then I'm going to comment out the rest of that. So in other words, we're basically factoring out this time, delta time, multiply times time, delta time issue. Let's just say, hey, rotate 45 degrees. Now, what does this say? update is called once per frame. Now I just showed you that my computer operates at 90 frames per second. So we're going to call this 90 times for every frame, right? 90 frames per second, every second rather. It's calling this 90 times, right? Because it says it's called once per frame. All right. So let's switch. Let me save my work rather. File, save, and switch back over here to Unity. And let's run the program and let's see what happens. Okay, so wow, that thing is really spinning. Now we are operating at about 90 frames per second. You can see that value for the z-axis is really spinning fast. Why is that? Because what we're saying back over here in the code is we're saying this update, we know that it's called once per frame. Every second, this thing is being called 90 times. So this function is being called very fast. And so we're rotating 45 degrees basically every time this update function is being called. And so that's why it spins really quickly. So if I didn't take this into consideration, one of the things I could do is maybe just put a 1 right there. So if this is going to be called once per frame, and I know that my computer operates at 90 frames per second, that means this thing is being called 90 times every second. In other words, we should rotate 90 degrees per second. So let's go ahead and save our work and see if that's in fact true. I'm going to go back over here to Unity. Where is that? Oops, sorry. Unity. And let's run the program. And let's verify first of all that we are at 90 frames per second. Yep, sure enough, about 90. And I'll take a look at this point right here. So 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, right? So for every second, this thing is rotating 90 degrees. Now, that's just because my computer happens to be operating at 90 frames per second for this game. You could have a faster computer at 120, so this thing should be rotating faster. Or maybe yours is running at 45, which means that this thing rotates a little bit slower, right? I'm just trying to explain how this works. Now, if I did want to do something like this, where I have the 45 over here, let's get rid of that comment and that extra parens as well, and the semicolon. And now you can see and maybe have a better understanding of how this time delta time works. It says the completion time in seconds since the last frame. Well, if my computer is operating at 90 frames per second, so that means that this thing is being called every 90th of a second. For every 90th of a second, do this job of rotating this 45 degrees, which means just a sliver of this thing is going to be actually rotating, right? It's not going to actually rotate it at 45 degrees. This is going to be multiplied times a tiny little sliver, 1/90th of a second, times the attempt of rotating this 45 degrees. So if I click File, Save, and go back over here to Unity and then play the game, now I think you have a better understanding, or at least, hopefully a general understanding of how we are rotating this thing 45 degrees every 1/90th of a second, and attempt to try to do that, and attempt to try the next sliver to rotate it 45 degrees, or a fraction of that, I should say. 1/90th times 45 times 1/90th times 45 times 1/90th times 45, so forth and so on. So that's the whole purpose of why you would need that multiplier. Of course, you saw that I did it a different way. I just simply put the number 1 over there and didn't even worry about delta time, and that basically does the same thing. Hey, let's play around with this. So let's make this a 0. We know that this is the z-axis, and this guy over here is the xy axis. Let's see what happens. Let's go ahead and save my work. Now, by the way, instead of clicking File, Save, I'm just going to hit Command S on the Mac. So Command S, let me switch back over here to Unity, and let me click Play. And so now we should see rotation amongst the x-axis. So the x-axis is like this, and sure enough, you see this thing spinning amongst the x-axis. This is not a three-dimensional object. This is a 2D sprite, so it makes sense that it would look like this. This is like a coin flipping from left to right. All right, let me go ahead. Sorry, I meant to stop the game first. Then I'll go back to Visual Studio, and let's see what happens now if I were to change, instead of making this 45, I'll make this 45. So this is the x-axis, this is the y-axis. I changed the y-axis, sorry about that. And so now let's go ahead and save this, and let's go back over here, and I changed the x-axis, and so let's see what that looks like. Okay, so you can see what happens here. We are rotating amongst the x-axis. So the way that I described it last time was a little confusing. Let me re-describe this. Imagine a line here, and it's poking through a little potato, a 2D potato, and continuing here. Now we're going to take that line and we're going to spin it this way. So this means rotation amongst the x-axis. And so there's a line right here that we're spinning in this direction. Now I'm going to go back over here, type in a number 45. Now we're going to spin amongst the y-axis. So let me save, run the program again. All right, so now there is a line from the top to the bottom. It's poking through that potato and it's going all the way down. And so now we are going to spin amongst the y-axis, and you can see that behavior. In fact, you want to see something really funky? Let's make all of these 45. So we'll make the x, y, and the z-axis 45. Let's see what that looks like. So I'm going to run the program, and we should see kind of like a diagonal type of spinning, and sure enough, that's what it looks like. And that makes sense for a two-dimensional object. If this were a three-dimensional object, that would look really cool, right? But we're not worried about a 3D game at this point. I just wanted to encourage you to play around with these values, to study them, to see what kind of effect that it has. So let me go back to what we originally had, which was 0, 0, and then we had the 45. I will save my work, switch back over here to Unity, and then play the game. And then so now we should see a nice smooth rotation for this particular pickup. And then if you want stats, you can include that. If you don't want stats, you can just click on it again, and that would be fine.